Hello, I'm Patty Simpson with Simpson Math. Let's talk about the conclusions that we make when dealing with hypothesis tests. There are two different conclusions we can come to. The first is to reject the null hypothesis if the test statistic calculated is found to be statistically significant. In other words, it is far enough away from the population parameter for us to consider it statistically significant. Then we reject the null in favor of the alternative hypothesis. Our second thing that can happen is that we can fail to reject the null hypothesis if our test statistic is not statistically significant. So let me explain a little bit. First of all, always picture a court room where a defendant comes in and we are presuming that that defendant is not guilty unless we get enough evidence to be able to say that the defendant is guilty. We have to collect enough evidence. The same thing is true with our hypothesis here. Our null hypothesis, we're going to presume that it is true unless we get enough evidence that we can go, we reject it. But we have to collect enough evidence. Then in the courtroom with the defendant, we never say that the defendant is innocent. If we don't get enough evidence to say that he's guilty, then we say he's not guilty. We never say, though, for sure that he's innocent. It just means we didn't collect enough evidence to show that he's guilty. So we say he's not guilty. The same thing's true with our failing to reject the null. When we have a null that we don't get enough evidence for, we don't say that that null hypothesis is true. Instead, what we do is we say, well, we don't have enough evidence to reject it. So we're going to fail to reject it. Let me give you a small picture to deal with. We know that when we go out and collect a sample and we find a mean from that sample or a proportion from that sample, that's part of a sampling distribution. So if we have our sampling distribution and we take the mean of that sampling distribution, we expect our test statistic, well, we know our test statistic falls into that sampling distribution. And we know that if it's in a normal curve, that within one standard deviation from the mean, it's going to fall there 68% of the time. If it's within two standard deviations from the mean, it's going to fall there 95% of the time. And then within three standard deviations is 99.7% of the time. So we decide how far out is far enough for it to be statistically significant. But let's say I go out and I collect that test statistic. I collect that test statistic and it falls way out here. Well, then I say, hey, that is statistically significant. And if it is way out there and we say it's statistically significant, then we reject the null. We say, hey, we reject you. And it gives us evidence in favor of whatever our alternative hypothesis was. But if when I collect my test statistic, it falls, somewhere in here where I expect it to be, well then that's not enough evidence for me to be able to reject the null. So in this case, I'm going to fail to reject the null. It's not far enough out for me to reject the null. I failed to reject the null. And so I did not gather enough evidence for my alternative hypothesis. So here I fail to reject, whereas this one, we would reject the null. So those are our two different outcomes. Now we can make mistakes, and we'll look at that in a little bit. There are different errors we can make because it is possible to get something that far out there even when the mean is here. So we might reject the null even though we shouldn't. Just like sometimes we put a defendant in jail when actually they're not guilty. And then we could fail to reject when it turns out that that mean is wrong. Just like sometimes we don't put a defendant in jail, we say they're not guilty when they really are guilty. So we can make those same errors here as well. We'll look at that though later. So the two conclusions we can come to are to reject the null and to fail to reject the null. Let's look at an example here. At Northwest Community College, syllabi for online classes state that students should expect to spend 10 hours a week doing coursework for each 3-hour course credit. The director of e-learning for the college is concerned students are being required to spend more than 10 hours per week doing work for each class. We looked at this earlier and we saw that our alternative hypothesis, that the e-director said that the mean was going to be more than 10. So that meant that our null hypothesis was that it was less than or equal to 10. Then a hypothesis test with a 5% level of significance is performed on the director's claim. Remember that 5% level of significance is the complement to our confidence level. So if it's a 5% level of significance, that tells me that it's a 95% confidence level that I'm dealing with. The result is to reject the null hypothesis. Does this conclusion support the director's claim? Well, we're going to reject the null. So let's look and see what's happening here. So my mean is here at 10. And if I reject the null, if I reject the null, that means that I got it statistically significant. It was far enough out here that I'm going to reject that null. And sure enough, if I reject this null, it means that there is enough evidence to show that the director's claim may be correct. In which case, maybe we need to switch those syllabi to say, hey, it's going to be more than 10 hours. Or the e-learner director needs to go to the teachers and say, hey, it turns out it's taking longer than what you expected. Maybe we need to narrow this down a little bit. So that when we reject the null, it does support our alternative hypothesis. Let's look at another example. Here's another example. Based on historical data, the Board of Education for one large school district believes that the percentage of high school sophomores considering dropping out of school is at least 10%. A high school counselor believes that the percentage is too high. A hypothesis test with a level of significance of 2% is performed on the counselor's claim. The result is to fail to reject the null hypothesis. Do the findings support the counselor's claims? First of all, this level of significance of 2% tells me that I need to have a test statistic that is out far enough that it is at the 2% probability that I get it. Or we could say that we have a 98% confidence level. So here the result is to reject the null. Remember that again, when we collect our sample, our mean would be here in the middle. In this case, it would be 10%, or in this case, a proportion. Our proportion would be in there in the middle, 10%. And our alternative hypothesis here, the counselor is claiming that that proportion is less than 10%. And then the null is that it is greater than or equal to that 10%. So we're going to take and we're looking for something small enough down here to support that counselor's claim. The counselor's looking for enough evidence that it's way down here and it's 2% chance down here that we would get that test statistic. And then we would say it's statistically significant. The result is to fail to reject the null. Notice if I'm failing to reject the null, that means it's closer in here. So their test statistic was not statistically significant. So that did not support the counselor's claim. Instead, we say that we fail to reject this. It doesn't mean that that's true. It just means we did not get enough evidence to say that we reject it. So it does not support the counselor's claim. So those are the conclusions that we can make from hypothesis tests. Math Made Simple is Simpson Math. Thanks for watching.